there, mathematicians, it's Justin again. In our last lesson, Mia was preparing for baseball tryouts. Well, guess what? She made it! But did you know baseball isn't just about home runs and stolen bases? Today, the team is up to something different. They're taking care of their practice field. This is where the team practices. This area here is called the infield, and the team wants it covered in grass, like this field is. They've got 8,100 square feet of infield to cover with grass seed, and the seed costs 15 cents per square foot. That's a lot of green, and I'm not talking about grass. So how might we figure out how much all this grass seed is going to cost? Pause the video here while you jot down your thoughts in your guided notes. I think we'll need to refresh our multiplying decimals skills. By the end of this lesson, you'll be able to multiply multi-digit numbers with decimals. Let's hit the practice field and help out Mia and her team. The infield is about 8,100 square feet, and grass seed costs 15 cents per square foot. To find the cost, we need to multiply. First, arrange the numbers vertically. Do you notice anything about how these numbers are arranged? They're not arranged by place value. Not to worry, when multiplying numbers with decimals, we can convert the decimals to whole numbers. Then we can solve, using the multiplication algorithm, the step-by-step process used to multiply multi-digit numbers. So how can we change 15 hundredths to a whole number? Well, as we move up to greater place values, each place value is 10 times greater than the one before. For example, if we multiply this 3 in the ones place by 10, we get 30. The 3 is now 10 times greater than it was in the ones place. If we multiply 3 ones by 100, we get 300. Now the 3 in the hundreds place is 100 times greater. If multiplying a digit by 10 shifts it one place greater, and multiplying it by 100 shifts it 2 places greater, how many places would it shift if we multiplied it by 1,000? Yeah, then it would shift 3 places greater. It follows the same pattern in the opposite direction with division too. 300 divided by 10 is 30. The 3 in the hundreds place shifted 1 place lower. We can multiply and divide by factors of 10 to shift digits to bigger or smaller place values. So, if we multiply 15 hundredths by 100, each digit shifts 2 places greater, and it becomes 15, a whole number. Now let's multiply 8,100 by 15. We always start with the smallest place first, so we'll multiply 8,100 by 5 ones. 5 times 0 is 0. 5 times 0 again is 0. 5 times 1 is 5. And 5 times 8 is 40. Now onto the tens place. Remember, because this one is in the tens place, we are multiplying each digit of the top number by 110. That's why we have to remember to record a placeholder 0 in the ones place on our second line. 1 times 0 is 0. 1 times 0 again is 0. 1 times 1 is 1. And 1 times 8 is 8. Now we just add these up, and we're left with the number $121,500. That is way too expensive for Mia's baseball team. Oh, I can't believe I almost forgot. Remember how we multiplied 15 hundredths by 100 to make it a whole number? We need to divide our answer by 100 to get our digits back into the correct place value. When we divide our answer by 100, each digit shifts 2 places smaller, and our answer now becomes $1,215. That's much better. $1,215 for grass seed is still pretty pricey, but Mia and her baseball pals have a game plan. A readathon fundraiser. A local business will donate 60 cents for every page they read. Mia read 185 and 25 hundredths pages. At 60 cents per page, how much money did she raise? Looks like we're going to need to multiply again. Because we're going to convert these factors into whole numbers, it'll be easier to leave off the placeholder 0 in 60 hundredths and write 6 tenths for our equation. To make 185 and 25 hundredths a whole number, we need our digits to shift 2 place values bigger. So we'll multiply by 100. We need the digit in 6 tenths to shift 1 place value greater, so we'll multiply by 10. Be sure to keep track of this information so we know how much to divide our answer by later. Pause here to finish multiplying. Our product is 111,150, but we're not done. To move the digits of our answer back into the correct place value, we still need to divide. We multiplied 185 and 25 hundredths by 100 and 6 tenths by 10, so we need to divide by 100 and 10. That's the same as dividing by 1,000, so our digits will shift a total of 3 place values smaller. Drumroll, please. Mia raised $111.15. Oh, no, don't be upset, Mia. It's okay that $111.15 isn't enough for the grass seed because you have teammates fundraising as well. Including Mia, there are 12 players on the team. If they all raise as much money as Mia, will they have enough to buy the grass seed? Mia raised $111.15, so we can multiply her total by 12 to find out. Pause here while you complete the calculation in your guided notes. After arranging the numbers vertically, we need to multiply 111 and 15 hundredths by 100 so that its digits will shift 2 place values greater, making it a whole number. Now we multiply. 2 times 5 is 10. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2. 2 times 1 again is 2. And 2 times 1 again is still 2. Add our placeholder 0 to the second line since we're multiplying by the digit in the tens place, and cross off that regrouped amount from multiplying the ones place just to keep our work organized. Then 1 times 5 is 5. 1 times 1 is 1. 1, 1, and 1. Now, add these up. And we have 133,380. Finally, divide by 100 to shift the digits of our answer back to their correct place value. If everyone reads at least as much as Mia, the team will have $1,333.80. That's enough for the grass seed. Thanks to your hard work, Mia's baseball team is out of the dugout and on their way to a beautiful grass-filled practice field. And you learned that multiplying and dividing a number by factors of 10 shifts its digits to bigger and smaller place values, and that numbers with decimals can be temporarily converted to whole numbers in order to multiply them. This field is looking great. Be sure to complete the practice questions and extension activities that go along with this lesson, because in math, just like in baseball, practice makes progress. Keep crunching those numbers and swinging for the fences, mathematicians. See you next time.